After talking to a couple of students about Lab 7 and Homework 2, I realized that there were a few concepts that we'd read in the book and that we'd gone over in class that it might help for me to go over again a little bit to help clarify them in your mind, because they can really make a difference in these in this assignment. And I noticed that some people were running into trouble with them. So first, I would suggest that if you're having trouble getting your in-room object to act like you expect, one thing to do is reread Chapter 3, or maybe look through Chapter 3 for anything that you didn't understand. Specifically, look at anything in the book that's about calling methods, calling constructors, and how variable scope works. We're going to talk a little bit about that in this video, but it wouldn't hurt for you to brush up on it either by looking at Chapter 3 and places in the book that mention the concepts that I just discussed. So, okay, we're going to look at this example program factory quickly to talk about what variable scope means. So, variable scope is the places in your program that a variable exists for. That may sound strange, like where does a variable exist? Well, it just exists where it is. Well, that doesn't really help you when you want to use the variable. It's important to know that a local variable exists only in its local scope. So for this method main, for example, these variables that were declared here in the main method only exist between these brackets. What does that mean, they only exist there? It means that number was declared here, therefore I can't use it in a different method. Like say number plus plus here. Eclipse is going to tell me you can't do that because number is actually not a variable here in this method. Number is a variable in a different method, and so we don't know about it here. It's important that local variables have scope that's limited to the methods they're created in. Why is that? Well, because when you use a name, it has to be you have to be able to determine what variable you're talking about later when you use that name. So if number only exists as a variable in the scope where it was created, then whenever you use the name number inside of this method, like if you use it here, for example, we know what number this refers to. We know what variable this refers to. This refers to this one. If I want to create a new variable called number in a different method, I'm allowed to do that. So this I can do. I can create a completely new variable called number in a different method. And the reason that this is okay is because I'm allowed to treat the local variables in my method as if the outside world doesn't even exist. And this is really important because if you have a large program, you don't want to have to keep track of what names anybody else who's written anything in that program has used. You want to be able to focus on just writing your own method and focus on just the scope within this. So if you want to use, say, number as a variable, if it's a meaningful name to you here, it doesn't matter if someone's used that name in another method. You can use it here because your little world that you're working in only exists between these brackets. Okay? But it also means that you don't have access here to this value number. So if for some reason you wanted to use this number here, you can't do it. You can't do it the way this is currently written. So if you can't access other data, local data, from another method, then how do we ever get anything done in these programming languages when we're trying to do stuff with data? Well, the way we get around it is if a method needs some information that is from the outside world, one way that it does it, there are multiple ways, but one way that it gets access to it is the location that calls the method can use a parameter that is built into the method. What does that mean? Well, here's a method called triple that takes an int as a parameter. It actually also returns an int. So to do its job, it needs to be sent an int. Okay? When an int is sent in there, the value of that int is put in a variable like this. It's associated with this identifier, and it's treated like another local variable for the purposes of doing its job until this routine is over. Okay? So what that means is when I call triple here and send in number, the value of 8 then gets assigned to operator. And then while triple is running, it's like there's a local variable called operator that has the value that was sent in. Okay? So when you see a parameter like operator in a method, think of it as like another local variable that you can use in that method. Okay, so that's how you get data into another method to get around the fact that you don't have access to all the data in your program if it's tied up in local variables. Well, how do you get data to an object that you've created? Okay, so this factory, let's say it's going to make some widgets. So we've got another class called widgets. So let's say widgets. Actually, I want to call it, yeah, so, well, widgets is a bad name. It should be widget, but we're going to keep it widgets now for this video. Widgets thing 1 equals, well, we'll just say, yeah, equals new widget equals new widget. Oops. Okay, so we've created a new widget, and let's say that the only interesting thing about widgets is they have a size that's an integer. So once we have a new widget, how do we set its size? Well, let's look at the design, the current design of widget. So I've got a UML diagram for factory and widgets, and notice that widgets actually has a private member variable called size, and it's an int. The question is, from the outside, since we don't have access to directly change the size variable from the outside, how do we interact with widgets? Well, it looks like we can get the size. There's an accessor, but there's no mutator. We can't set the size. But we do have a constructor that takes an int. And let me say that, let's say you talked to or you read the documentation for this class widgets, and you learned that the way you set the size is by sending in the size as an int at the time that you create the widget. All right, well then let's do that. Let's go back to factory.java, and let's say, oh, I want my thing1 widgets. It has to be called widgets. I want it to be of size 35. Okay, so now this works. This actually is correct syntax because I'm saying widgets thing1 equals new widgets at size 35. We're creating a widgets called thing1, and we're initializing it to a value. Okay, so now instead of printing out that, we're going to print out thing1 get size. Okay, so we're going to call the get size method that we saw here in the design. This has already been created, and we're going to get the size back. So we set the size by creating the widgets, and then we're going to print it out so we can see if we were successful at doing this. All right, we're going to run. Oh, and we got in the console we got a 0. What happened? Something's gone wrong. We tried to set the size by calling widgets and sending in the size, but it didn't work. So let's look at the code. Maybe there's something wrong with the code. So this is a very simple program. There's not much to it here. It's got a constructor, as we saw in the design. There's the constructor and a get size, and it's got some data, and that's all that's here. You can see it right there. Okay. So what's going on? We send in size. Why didn't it set why didn't it set the class's field to size? Okay, well, if you remember from our previous discussion about how parameters work, when you have a parameter in a method, it treats it like a local variable. And in fact, that local variable exists only for the scope of that method, and so it only has meaning within that method. So if the int size here is like a local variable to this widget's constructor, then that means it's separate and different from this variable size. This variable is a field of widgets. Okay, it's a field, or it's a member variable. We also call it an attribute. It belongs to the object. This is local to the constructor. Okay, well, that means that in order to get the field to save the data that we've sent in when we created widgets, when we call this method, in order to save that data, to hang on to it, we need to assign the value that's been sent in, assign that to the to this field that is a part of our object. So how do we do that? They're the same name. That seems like it's a problem. We can't say size equals size, can we? Well, first of all, there's a question about, because we talked about not being able to access data from one method in a separate method, right? So if we have a local variable in one method like this, we can't access it here. Can we access a member variable in here? Yes. So this is different. So local variables can only be accessed within their local scopes, but a member variable, an attribute or a field of an object, can be accessed in any of the methods of that object. So we actually can get access to this size, but that's still confusing, because why can we get access, or how can we get access to that if the names are the same? We can't say size equals size, can we? Well, we can, but when we do that, we're actually talking about this local version of size. So we're just setting it equal to itself, and that does nothing. Okay, what we have here is a situation called variable shadowing. Okay? When you have a variable that belongs to the object, a member variable, and you have a local variable that has the same name, we say that in this local scope, that outer variable has been shadowed. It's been kind of obscured. We can't get to it just by using its name. But there is a syntax that allows us to get access to it. The syntax is this. The keyword "this" refers to the object that you've created of these widgets. It's the way that within a class you allow an object to refer to itself. Okay, so let me just explain that in the context here. This dot size refers to the member variable size. Just using the name size alone always refers to the local variable. So if we set this dot size to the local variable that was sent in, we will actually store size, and then size will exist so that it can be used later on when we do a get size on widgets. Now that I've made this change, let's go back to the factory and let's run the program again and see what happens. Now you see, I've set the widget size to 35. So when later I use get size in order to send it to the print statement and print it to the console, I get the correct value, which is 35. So you can also see this happening, and we'll do this quickly. You can see this happening if we step through it in the debugger. If you're not familiar with that, there's a video on that you can go looking for in my courses that explains how the debugger works. I'm going to assume you know how the debugger works as I do this. So I've run up to the point of my breakpoint, which is when the widget's object is created here. Okay, I'm going to notice that we're right here in this line of the factory program. When I step in, it's going to take me to the widgets class. Okay, and here in this object, notice that size has been, the number 35 has been sent in using size, but the local value of size is 35, but this other member variable is actually still 0, which is the problem that we had before. It was 0, and that's why 0 is being printed out to the console. So now when we step, we get to the assignment statement, and watch what happens in the upper right hand corner. The member variable gets set to the local variable, to the parameters value, and then we step again, we return back here, we end up at the print statement, and now when we jump back into the code for the get size call, and we look under this, you see that size still has the value of 35 because we set that when we ran the constructor. And that's why this program works now, but it didn't before. Okay? If that went by a little bit quickly, feel free to run the video again. And I hope that clears up something about how variables work and something about how variables in your objects are going to work. And hopefully that helps you in getting your constructors working and your getters and setters working for your project.